Welcome, everyone. Today, we are tackling a critical phase of MLOps, deploying machine learning models into production environments. Our main focus will be mastering progressive rollout and safe rollback strategies to ensure zero downtime, risk-free AI operations. Let's get started. Let's start with the core concept. What is a progressive rollout? In traditional software, deploying a new version often meant flipping a switch and hoping for the best. In MLOps, a progressive rollout is the strategic, gradual introduction of a new machine learning model to live user traffic. The basics are simple. Instead of replacing your old model entirely, you shift traffic in small, controlled increments. Why is this absolutely critical? Because a model that scores perfectly during training might encounter unexpected real-world data, known as data drift, causing it to fail. A gradual rollout minimizes the blast radius of those failures, protecting your end users. How do we achieve this? We use managed online endpoints in Azure Machine Learning, which allow us to host multiple models behind a single URL and control the traffic percentage. Diving deeper, this progressive approach perfectly bridges the inner loop of model development with the outer loop of production deployment, ensuring smooth, continuous delivery. Take a look at this routing architecture. On the left, our newly trained model leaves the model registry and reaches the managed online endpoint. This endpoint acts as a highly intelligent traffic cup. Notice how it splits the incoming requests. 90% of the live traffic is routed to the V1 stable deployment, ensuring that the vast majority of our end users experience no disruption. Meanwhile, 10% of the traffic is siphoned off to our V2 Challenger deployment. Both models serve predictions back to the end users, allowing us to safely test the new model's performance in the real world. A progressive rollout is only half of the equation. You must also have a safe rollback strategy. What is a safe rollback? It is the ability to instantly redirect all live user traffic back to a previous, known stable model version. The basics require you to keep your old model actively deployed and running alongside the new one during the transition phase. Why is this non-negotiable? Imagine your new generative AI model starts hallucinating, or your classification model's latency spikes, causing the consumer web app to crash. You need an emergency escape hatch to restore service immediately. How is this executed? You simply update the endpoint's traffic allocation rules, shifting 100% of the requests back to the original deployment. For a deep dive, understand that enterprise-grade rollbacks shouldn't rely on humans noticing a problem. They should be automated. If your monitoring tools detect that error rates have crossed a threshold, a script should automatically trigger the rollback. This state diagram illustrates the lifecycle of a safe rollback. We start in normal ops, where 100% of traffic flows to V1. We initiate the rollout phase, shifting 10% of traffic to the new V2 model. Suddenly, we transition to an error-detected state because V2 experiences massive latency spikes. Instead of panicking, the system immediately triggers a safe rollback, reverting all traffic back to V1. The system stabilizes, and we return safely to our normal ops state, completely invisible to the majority of our users. To manage these traffic shifts, we utilize the blue/green deployment architecture. What is this? It is a battle-tested software engineering strategy adapted for MLOps. It involves maintaining two identical production environments. Blue represents your current, stable model, and green represents your newly trained model. The basics are straightforward. You deploy your new model to the green environment in the background. Once it is fully loaded and verified, you switch the router to point traffic from blue to green. Why is this so popular? Because it completely eliminates downtime. There is no waiting for servers to reboot. Furthermore, if green fails, your blue environment is still sitting there, ready to take the traffic back instantly. How is this built in Azure ML? Blue and green are simply two different deployments hosted under the exact same managed online endpoint. For a deep dive, we often combine this with canary releases, where the green model only receives traffic from internal testers before we expose it to the public. Let's visualize the blue/green switch in this flowchart. User traffic comes in at the top and hits our managed endpoint router. Notice the dotted line pointing to the blue deployment. This represents the old route that has just been turned off. The bold, solid line points to the green deployment. We have just flipped the switch, routing 100% of traffic to our new V2 model. Both deployments are connected to the same logs and storage, ensuring our data continuity remains completely unbroken during the transition. Executing a progressive rollout manually is risky. Therefore, we must automate deployments using GitHub Actions. What does this entail? We use GitHub Actions to automate the orchestration of our model deployment and traffic allocation. The basics mean that instead of a data scientist manually clicking through the Azure portal to shift traffic, we write YAML scripts that execute the Azure ML CLI commands for us. Why is automation a requirement? Because manual deployment is prone to human error, typos, and is nearly impossible to audit for compliance. CI/CD pipelines ensure that every rollout is repeatable, secure, and permanently documented. How does it function? When a new model is registered, a GitHub workflow triggers automatically. It deploys the model with 0% traffic, runs automated sanity tests, and then shifts traffic to 10%. Diving deeper, the specific mechanism involves executing the AZML online endpoint update command inside your pipeline, dynamically adjusting the traffic flags to manage the rollout mathematically. Follow the sequence diagram to see GitHub Actions in motion. The process kicks off when a model registered event occurs on the main branch. GitHub Actions intercepts this and commands the Azure ML endpoint to deploy v2, but strictly with 0% traffic. Once Azure signals the deployment is ready, GitHub runs automated API tests against the new model in isolation. After the tests pass, GitHub sends the critical update command, shifting the traffic split to 90% v1 and 10% v2, safely concluding phase 1 of our automated rollout. While automation is incredibly powerful, enterprise MLOps requires a human in the loop. We achieve this using gated approvals and environments. What is this? It involves utilizing GitHub environments to enforce physical checkpoints before advancing a rollout. The basics involve defining logical environments, such as staging and production. Transitioning a model from staging into production requires explicit, authenticated human permission. Why do we pause our automation? Because even if automated tests pass perfectly, business stakeholders or compliance officers need to review the real-world performance metrics before a model is exposed to 100% of your public users. How is it configured? You set up an environment in GitHub repository settings, designate required reviewers, and link that environment to your YAML workflow jobs. For a deep dive into security, this perfectly fulfills zero trust principles. Even if a bad actor compromises your training script, they cannot push a malicious model to the public because the hard human approval gate will physically block the pipeline. This flow highlights our gated security posture. After automated training, the model is deployed to staging. Then, the pipeline hits a wall, the human approval gate. The workflow pauses indefinitely here. If the reviewer rejects it, the pipeline halts. If they approve, it proceeds to deploy at 10% in production. We then hit a second gate, monitor, and approve 100%. Only after reviewing the 10% traffic metrics does the team click approve, authorizing the final, full production rollout. When your model is sitting at 10% live traffic, you enter the most critical phase, monitoring. What does this mean? It is the continuous observation of key performance metrics while the new model is actively processing live user requests. The basics involve tracking operational data points like response latency, HTTP error rates, and CPU utilization. Why is this non-negotiable? Because you absolutely cannot decide whether to push a rollout to 100% or trigger an emergency rollback without objective, real-time data. You cannot manage what you do not measure. How do we collect this data? By deeply integrating Azure Monitor and Application Insights with our managed online endpoint. Let's take a deep dive into modern AI. If you are deploying generative AI applications, part of GenAIOps standard IT metrics aren't enough. You must also monitor token usage to control costs and track content safety filter triggers to ensure your new language model isn't hallucinating or violating enterprise compliance boundaries. Look at how telemetry drives our decisions in this architecture diagram. Live user traffic hits our V2 model. As it processes requests, it sends a continuous telemetry stream down into Azure Monitor. Azure Monitor splits this data into actionable dashboards, latency metrics, error rates, and token usage. All of this data feeds into our decision engine, whether that is a human reviewer or an automated script. Based purely on these metrics, the engine makes a binary choice. If metrics are good, proceed with the rollout. If metrics are bad, immediately trigger the rollback. Even after a successful 100% rollout, our job isn't finished. We must constantly be vigilant for data drift. What is data drift? It occurs when the live data being sent to your production endpoint significantly diverges from the historical data used to train the model. The basics are a reality of data science. Over time, All models degrade because the real world evolves, consumer behavior shift, and economic conditions change. Why do we care about this during deployment? Because detecting drift early is the primary trigger for initiating the next MLOps retraining lifecycle. How do we detect it? We use Azure Machine Learning data monitors. These monitors continuously compare the statistical distribution of your baseline training dataset against the real-time inference data flowing into your endpoint. Diving deeper, this is how we build self-healing systems. When the drift metric crosses a specific threshold, Azure sends an alert that automatically triggers a GitHub action to retrain the model, seamlessly starting our progressive rollout process all over again. This flow illustrates the ultimate continuous deployment loop. The production endpoint sends its daily inference data into the data drift monitor. The monitor constantly asks, is drift detected? If no, we continue monitoring peacefully. If yes, and it exceeds our safety threshold, it immediately fires an alert to GitHub Actions. GitHub Actions wakes up and triggers the retraining pipeline. Once the new model is trained, it naturally flows right back into our start new progressive rollout phase, completing the MLOps lifecycle. Let's tie everything together with a critical, real-world use case. Consider Prosware, a rapidly growing healthcare startup. They developed a diabetes classification model that is deeply integrated into a web application used daily by medical practitioners. The challenge arose when they detected data drift. The model's accuracy was degrading, requiring an urgent update. However, because this is healthcare, any downtime or sudden burst of inaccurate predictions could severely impact patient care. They needed absolute stability. The solution, they implemented this exact MLOps strategy. Using GitHub Actions, they initiated a progressive rollout. The new diabetes model was deployed to a green environment on their managed online endpoint. They shifted exactly 10% of practitioner traffic to the new model. During this phase, Azure Monitor scrutinized the response latency and diagnostic accuracy. Once the metrics proved the new model was vastly superior, a lead data scientist approved the GitHub environment gate. Traffic was smoothly scaled to 100%. The practitioners received a life-saving AI update with zero disruption. Our final diagram maps Prosware's exact journey. It starts with data drift detected, leading to training the new diabetes model. A GitHub action executes the deploy green step. We route 10% of app traffic to the new model and pause to review health metrics. If the metrics were failing, the system would take the bottom path, executing a safe rollback to blue. But because the metrics were stable, the flow proceeds to the human gate approval. The lead scientist signs off, and the system automatically scales to 100% green traffic, successfully completing a zero-downtime healthcare deployment.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.